Find the volume of a solid formed by revolving the region bounded by the curves y equals 2 minus x squared and y equals 1 around the line y equals 1. Ugh. Leave your answer in terms of pi. Alright, so this is what's going on here. We have this picture, 2 minus y squared. We're cutting it around here, and rather than spinning it around the x-axis, we're spinning it around here and creating this like weird shape that's going to look almost like a football, an oblong figure. Okay, so we're creating that. And since we're not spinning it around the x-axis, we're spinning it around another thing. We need to kind of use a reimagined version of the disk method. So the disk method is pi whatever squared. Okay, this is slightly different. The disk method around other axes is going to be the integral from a to b of pi, and then we're going to take our function that we're given, which is f of x, subtract the axis that we're spinning it around, which is g of x, and squaring that whole thing dx. So the f of x that we are going to use as our top part and the g of x that we're going to use as our bottom part are going to be these two guys right here. Now, before I can even begin this stuff, I have to find out my limits of integration. So my limits are going to be found by setting 2 minus x squared equals to 1 so I can find out where these two lines intersect. So why don't I subtract 1 to get 1 minus x squared equals 0. Why don't I add x squared so I get 1 equals x squared, square root everything, not forgetting my positive or negative, and my limits are going to be positive or negative 1. Okay, so let's set this god-awful mess up. All right, we have the integral from negative 1 to 1. Let's move the pi out front because I can. That is going to be f of x is 2 minus x squared minus g of x is 1 dx. Okay, don't forget the squared. That becomes pi from negative 1 to 1 of 1 minus x squared squared dx, which before we even integrate can be changed even further by squaring that whole parentheses, which is a perfect square trinomial. So 1 minus 2x squared plus regular x to the fourth, close it, dx it. Now it's time to integrate. Pi is still going to live out there. All right. The integral of 1 is x. And then we have negative 2x squared, which becomes negative 2/3 x cubed. And then we have x to the fourth, so plus 1/5 x to the fifth, with my limits existing at negative 1 to 1. Now we plug stuff in. Pi times 1 minus 2/3 1 cubed plus 1/5 times 1 to the fifth minus pi times negative 1 minus 2/3 negative 1 cubed plus 1/5 times negative 1 to the fifth. Okay, lots of same numbers are going to be repeated, just opposites. All right, pi is still out there. We get regular 1. This becomes 1, so times negative 2/3 is negative 2/3. This becomes 1, so times positive 1/5 is positive 1/5 minus pi. Okay, you're still negative 1. You become positive 2/3, and you become negative 1/5. Okay, common denominators of 15 are going to change that first bracket into 15 over 15. Multiply u by the 5, so minus 10 over 15. Multiply u by the 3, so plus 3 over 15. Minus pi Do the same exact thing. You become negative 15 over 15 times u by the 5, so plus 10 over 15, and times u by the 3, so minus 3 over 15. 15 minus 10 plus 3 is 8, so we get 8 over 15 minus pi times negative, same thing but negative, 8 over 15. This becomes 8 pi over 15, double negative plus 8 pi over 15. Add the 8 pi plus the 8 pi, 16 pi over 15 is going to be our answer. Barf City. Barf City.